Hi, and welcome to section 5 of scikit-learn recipes. In this section, we are going to look at decision tree models in scikit-learn. In the first video, we will be building a decision tree model. In the second video, we will evaluate and fine-tune the decision tree model. In the third video, we will be building a random forest regressor. Then we will build a k-nearest neighbor model. And then finally, we will build a baseline gradient boosting model and then improve its performance. In this video, we are going to build a decision tree model. Specifically, we're going to build a decision tree classifier. So let's import decision tree classifier from scikit-learn.tree. And we're going to build a model on the sales, loss, and win data. So as we did in the previous videos, we are going to encode all of our categorical variables. And as we can see, what we did before also is that we encoded all of the categorical variables. This was first text data, and now it is all numeric data. So a decision tree algorithm is a non-parametric supervised learning, machine learning method for classification and regression. The goal is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. You can click on this link to learn a little more about decision trees. There are a few advantages and disadvantages of using decision trees. Mainly, decision tree learners can create overcomplex trees, which means that they overfit the training data and they don't generalize very well, which is why random forest is really good because it does not overfit data, but we will talk about that more later. So here we're splitting the data into X variable and Y variable, splitting our data into training and testing sets. First, let's run the default criteria for scikit-learn's decision tree classifier, which measures the quality of each of the tree splits using Gini index. What this basically does is that at every split, it will check what performance of that split is based on something called the Gini index. And then we will use entropy, and entropy checks to see at each split how much information is gained. These are two different methods of checking purity of each of the splits. And the purity means like how true or how well was it able to distinguish whether it is a positive or a negative outcome. So as we can see over here, our accuracy using the Gini index is higher, but not very much higher than using entropy as a measurement of the quality of the tree splits. So this was a really quick decision tree classifier model. There are ways to improve this model by tuning the hyperparameters, and that is something that we will go over later.